So what I want to talk about today is how community operates in the context of open source software. And yes, and I'm Karthik Ram. I'm at UC Berkeley and affiliated with the Division of Data Science. And like many people in this space, I wear many different hats. And so the hats that I'll talk about today all relate to open source software. And so I'll talk a little bit about the rOpenSci project, which I co-founded in 2011. But I'll also briefly mention two other projects that I'm actively working on now. One is the US Research Software Sustainability Institute, or URSSI. It's meant to be the counterpart to the SSI, but for the US. And then this newly launched program that I'm working on with Lou and others at CSCCE. It's the POSE program, Pathways to Enabling Open Source Ecosystems. So it's really hard for me to talk about success in open source and really point out very specific examples of what a successful community is and ones that haven't quite succeeded. But what I can give you in this context is my own experience founding an open source project that's been around for over 10 years now, and talk about some of the things that we have experienced with respect to community and how things have evolved over time. And so that's what I'm going to spend a good chunk of time on, which is the rOpenSci project. So we founded this project in 2011, where a whole bunch of things were going on at that time. Planking was very popular, but thankfully that did not survive for very long. But it was also the time that open science and open source was becoming a hot topic. There's a lot of conversations about open access. People were talking about making sure data was shared, code was shared. But I think the motivation for me during that time was that all this conversation about reproducibility was finally coming to a point where it was practical for the average scientist to do. So we had this concept of executable notebooks that were easily available, and people were mixing code and data together in these documents. But of course, researchers were not really sharing the notebooks. They weren't really sharing the code. And then they were writing one-off bespoke solutions to problems that many others faced at the same time. And so this was my big frustration and the biggest reason to start rOpenSci, which is that we wanted people to take code written to solve specific problems and turn them into reusable software. That's kind of what we wanted to do. And so when we started, we had a very simple purpose at the time. We wanted to go after high-value data sources and high-impact open science platforms, build software that is well-designed, well-maintained, and then hand it off to researchers. So it was a lot of, we'll build things for you and then hand it to you and then maybe get some feedback and then improve upon that. But of course, as you can imagine, from a community perspective, that didn't really scale. We're a nonprofit, fully grant funded, and we can only have so many engineers. And so we quickly moved on to accepting contributions from the community. And so people who built software in sort of whatever way they knew would come to us and say, would you like to adopt this puppy? And we'll say, the puppy's not potty trained, so we're going to have to work with you to get this up to code. I'm very sorry. And then bring that into our collection. And that was a very, very time-intensive process because lots of conversations, we'd repeat the same things over and over again. And pretty soon we started collecting all this into a living document, which is our developer guide. And it's been around for a long time now. It's released several times a year. And it now has guidance for people who might author a package, who might review someone else's package. And we just use that as a place to sort of capture all the best practices and the state of the art on how to do anything related to software development. So that's kind of where we are now. And then pretty soon we transitioned from working with researchers one-on-one to then just creating a system to accept submissions in a very systematic way and peer review them. And so Similar to how a journal operates, we accept submissions that fit one of many areas of interest that we support, and then work through checklists, have automation. We assign reviewers just like a standard peer review. So we get a technical reviewer and someone else with domain expertise to carefully look at the package. But that's where the commonalities with peer review ends. After that, we're quite different. So it's not just a one-off interaction. We actually do a lot of back and forth. Our goal is not to accept or reject. We always are gearing towards acceptance. And so we work on it as long as it takes to get the software into a much better shape and then accept that into our collection. And this process has been wildly successful. And to me, a good measure of success in this type of work is adoption in other communities. So this process was adopted by JOSS, and it was actually the inspiration for JOSS, which is now a wildly successful journal where people get to publish papers about their software. And it's also inspired rOpenSci, which is a community trying to do pretty much the same thing, but for the Python community. And lately, we've been working on a system that allows different communities of practice to then create their own rOpenSci without having to do everything that we did for the past decade. Of course, this is still missing the community piece. They still have to bring that piece and bring all of their tools. But we've set up the infrastructure now that people can easily build, deploy software in a very sustainable way for their own community. So this project has gone through many different phases over the past decade. We're still operating in all of these different phases. And those of you that have been paying attention to the community engagement course might notice that this is just pretty much the community engagement model that CSCCE tries to talk about all the time. And so it's been nice to see that we accidentally mapped onto this in our evolution without really trying to do so. And now we're also doing a champions program to sort of bring more people into the fold. So with rOpenSci and some of these different efforts, when I try to think about what is the change we'd like to see in this community and how do we think about this through the lens of a particular theory of change, I love this pyramid from Brian Nozick at the Center for Open Science, which we adapted into an interpretation for a paper that we published last year, which is that if you want to get the community to a certain point in time, which is that in our case, we want people to write reusable software that is well-developed, well-maintained, and available to the community, there's a process to getting them there. And for us, when we started rOpenSci, it was really difficult to write software. Documentation was non-existent. The only place you could get any advice was this mailing list filled with angry men. And it's still the same case. If I go in there now, people will just bark at me for being stupid. But so during that time, our mode of operation was build and share with the community. But then other organizations in the space built a better user experience around this process. And so it was easy for others to create their own tools. So we kind of pivoted to helping the community build their own tools and then grow this community of practice around people that care about research software. And then, of course, JOSS and other practices like the RSE movement came around as incentives. So people that were really excited about building software but didn't want to become a tenure track academic found ways in which they could have career progression. So it feels like if you want to implement some policy around research software, we've gone through the steps to actually make it possible. And I think that in some ways informs how we engage with the community. So going back to the prompt that I had from Lou and Katie, which was, what does success look like for an open source project? It's a tough question to answer because it depends on two things. It depends on what phase of life cycle you are in with respect to your project. Did you just get started? Or have you been around for a long time? And then the second one is what is your community? Who are you trying to serve? So do you primarily have a community that are other developers, Or do you have a user community, people who actually consume your tool or service, but don't actually contribute back? Or in some cases, you have both. And so an easy way to sort of classify all this is using Nadia Iqbal's categorization of open source projects. And so some of these are federations. You've got a large number of users, large number of developers. You could have clubs where all the developers are really the users. And a lot of academic open source projects and some really popular ones are basically stadiums. You've got a small number of contributors, but a large number of users that don't really care about participating in the development of that. And of course, academics have various one-off niche projects that are not really designed to help that many people. It's meant for either one lab group or a couple of different lab groups. So trying to get an understanding of where you are in the space and where you are in a particular life cycle of your own project. Because rOpenSci started as a club, and now we're not quite a federation, but we're somewhere in between. And projects can easily transition across these different phases. Hopefully you don't go from one of these down to a toy, but you might just start there and stay there. And so another way to sort of think about community in this context is thinking about metrics. And I know Josh mentioned chaos. And chaos is like a really useful way to think about community metrics, because they've done years of thinking in working groups to think about how people contribute to a project, thinking about different focus areas about people and time and so on. And so chaos has a ton of different metrics that could be brought to bear on community health. And I'm not here to really talk about chaos. Matt is actually here on the call, so if you have any chaos questions, you should direct that at him. But the only point that I want to make is that chaos has different metrics that speak to all these different areas, but it's really community that underlies almost everything except a few of the metrics. So how many people contribute, who they are, where they are, and then how long does it take for these contributions to get accepted, but also measures of risk. Is there just one organization that is largely supporting an effort, or is there a diversity of organizations and people contributing to an effort? So thinking about these metrics with respect to your project, based on where it is in a life cycle, is really helpful when you want to think about community and community health. And then I'll end on thinking about one of the points that Lou made. I don't remember exactly what she said at the start, but one of the things that she talked about was this community managers, this catch-all position that you're expected to do everything. And so I found this on opensource.com about what a community manager does in the open source context. And it sounds like they're expected to pick up everything and run with everything. So they're basically do all the work that is not already defined. And this explains why there's a lot of burnout in the space and lack of clear directive on what it is you are trying to do for a community. And so I think the work that CSCCE has done has been super helpful for us. When we hired a community manager in 2015, that's when I believe the first cohort of the engagement program kicked off. And so we benefited quite a bit from having our CM go through that process. And also watching the skills wheel come together has been really helpful to sort of try and define what it is you want your community manager to do for your project to reach the end state that you would like to be in. And so I think this is all super helpful in this space. And I just want to briefly mention that the other two efforts are sort of scaling up what we did with rOpenSci, with one language community and a community of practice around people that wanted to develop software packages, to really thinking more broadly about supporting people that are interested in developing research software as a whole. And now the new training that CSCCE and I are sort of kicking off is thinking even more broadly about ecosystems. So not just the open source software, but also hardware and data, and what are some practices and themes that help communities become sustainable in a way that is not just more funding. So yeah, that's all I have to say about this, and I'll stop here.